Questions while we're waiting? So I could see that there were lots of questions, but everybody was afraid to ask them in front of the rest of the class, no pun intended. Afraid to ask them in front of the rest of the objects. Any questions before we start? More on design patterns. We are almost out of leftover Halloween candy. Okay, so we were talking about the factory design pattern and this UML representation. And I made little notes about what the diamonds mean to help myself remember. This is helpful, by the way. This slide is actually helpful. It's one way to look at how this works in practice. Here's our factory pattern demo application. Here's the main method. It instantiates a new shape factory. And then the shape factory, whenever it needs something, it says, please get me a shape, and it specifies the name of the shape, right? And then shape has a draw method, for example. And here it is again, exactly the same, except this time we're specifying a rectangle. And then we have a generic shape parent class. We have a circle child class of shape that says, okay, override the draw method, and then we have a shape factory that overrides get shape. It takes the string and it's just a case statement. If the shape is null, return null. That would be a good time to print out an error message, by the way. If it looks at the string and then if it's circle, it returns a new circle. If it's a rectangle, it returns a new rectangle. Can anybody see another flaw with that method? There are some flaws here. It's hard to write perfect code, by the way. Anybody see another flaw with this method besides you've passed a null string into this method, and it should at least spit out a warning. Anybody see another flaw there? Name? Francesca.
It keeps returning null instead of after you're saying it back, as you said.
That's true, yes. It's not the answer I was thinking of. So it could return like some error message instead of null. Someone else had their hand up? Name? Alex.
You could technically set a string that's not in the factory and it wouldn't go off to.
Very good, Alex. That's what I was thinking about. Oh, that was way off. Yeah, what if I pass a string that just said like ellipse? This thing would just return null. So it would be nice. There should be another statement here. The else statement is missing. Like what if you've passed some string that it doesn't recognize? Anyways, but still, you get the idea behind the design, the factory pattern. Hopefully, that's the idea behind it. So here's the so-called participants. There's the abstract factory class, there's the concrete factory, the abstract product, the product, and the client, right? Those are the participants in this pattern, this design pattern. So the abstract factory returns concrete objects, right? and it returns a pointer to the concrete object. I don't know if we actually talked about pointers. Do you guys talk about pointers in any of your modules? I think you took a C module in your first year and you talked about pointers, right? This prevents the client from knowing anything about the actual creation of the object, so it's outsourcing the creation of the objects, making them abstract, and putting all the logic into a special class. And it's easy to add new concrete types there, right? It would be very easy to add another shape here called triangle, for example, or any shape. Very, very easy, right? You just have to add a new if statement, add a new child called triangle, and then override the draw method. So very, very easy to extend. Okay. And I think we all know how it can be used, right? We've seen lots of examples, the drawing editor example, the games, like video games, Tetris, and so on. Okay, so there's another pattern called the adapter pattern, which falls into this structural category or subset of design patterns. It involves a single class which is responsible to join the functionalities independent or incompatible interfaces. That's not very, very difficult to imagine. The class adapter relies on multiple inheritance. The object adapter relies on object composition. Right, here's a UML representation of the adapter pattern being used, right? This is the interface, the media player, and it has a method called play, right? And play is dependent, the audio player is dependent on the media player, and the media adapter is dependent on the media player, right? It has a media adapter class, the audio player, and it overrides the play method, right? And here we have an advanced music player member and the media adapter handled to the media adapter, and it also overrides the play. And here we associate the adapter pattern, this is the main class, right? And it's associated with the audio player, which uses the media player adapter pattern. And then the abstraction, the actual implementation is in the MP4 player, which overrides the play method, and the VLC player, which also overrides the play, or offers an implementation of the play method, right? So this is an interface class, and this is an interface class. So an audio player device can play MP3 files only and wants to use an advanced audio player capable of playing VLC and the MP4 files, right? So it needs this media adapter class to be able to handle the additional VLC files. Observer patterns. An observer pattern is used when there is a one-to-many relationship between objects, such as if one object is modified, its dependent objects are to be notified automatically. Can anybody think of a common example of the observer pattern in our daily lives? Anybody think of one? It's a good thing we're covering this material. My kind of favorite example is YouTube, right? When your favorite YouTuber uploads a new video and you're subscribed, then all the subscribers are notified, Right, that's a nice example of the observer pattern, so everybody gets notified when there's a new video uploaded. So the observer pattern is inspired by the behavior of news. A newspaper publisher goes into business and begins publishing newspaper, and if you subscribe to that newspaper, it gets delivered to you. In the old days, there were physical papers that were given to you. You see those in the movies. I had a job, by the way, that was my first ever job, was delivering newspapers. And I got fired. Because I wasn't good at waking up on time and getting them all delivered by 7:30 a.m. And as a result, all my clients unsubscribed from the newspaper. So some other simple relationships, publishers and subscribers. Publishers is in this case called the subject, and subscribers are called the observers in this design pattern. We can characterize the coupling between these two objects. Two objects are loosely coupled if they interact, but they have very little knowledge of each other. We kind of talked about this already in the object-oriented design when we talked about container classes. I don't know if anybody remembers that. Composite versus container, the composite versus container relationship. It does not need to know the class of the observer. We can add new observers at any time, irrespective of the state of the subject object, without modifying the subject object, right? So new people can subscribe to the YouTube channel. And of course, that YouTuber doesn't have to know about all the individuals subscribed to their channel. Changes to either subject or object don't affect one another. So that's a loose coupling. And by the way, somebody asked about this during the break. Java supports the observer pattern, the design pattern. It's built into the language. Before you implement any design pattern, check to see if Java already has it built in or has some support for it. Chances are you will never have to implement a design pattern from scratch. It'll either be supported inside the Java library, the standard library, or somebody will have published an implementation of it somewhere. But you'll have to do some homework, right? I haven't done all the homework personally. And I believe this one is in the coursework, right? The model view controller pattern. This is a subset of Bob's generic pattern, design pattern, which had the user interface. In this case, the user interface corresponds to the controller, the subsystem that handles the user inputs. The view corresponds to the output in Bob's generic design pattern example. So the view is the output. It's like what appears after the user has, one, specified the user input, and two, the processing unit or the processing subsystem has done its job, right? Then it provides some output. And the model corresponds to the data, like whatever data is necessary. So this is one of the classic design patterns, very popular. And so it's a subset of Bob's generic pattern, so it's going to be applicable to many different kinds of applications. So loading and storing the data, that corresponds to the M. Constructing the user interface, that corresponds to the controller. And then interpreting user actions, that also corresponds to the controller. These tasks can be organized into subsystems. The model view and controller can each be a subsystem. So that's the idea, the theory, right? You can think of the input, output, and then data storage. Actually, you could divide the model into two halves, like data interface and processing logic, right? That's Bob's generic pattern. So the model is the data interface communicates with the data source to read and write the data like a database or a network interface and so on. I'm going a little bit fast because it's just not very exciting. The view is the visual representation of the data. So the output, right? The output could be a graphic. In your coursework, it's a game. It's like you're watching things move around and playing the game. It could be something else, like any kind of output, right? Graphs, charts, reports. In a typical application, it's a report, like the world's most generic piece of output. The world's most boring piece of output is a report. Can anybody think of a common report that you get as output from your favorite software that you use probably regularly? That's a difficult question, probably. But your bank application, right? If you have, everybody has a bank app on their phones or on their desktop machines or a web page. The typical output from your bank application is just a report, a statement of all your transactions. So a statement of all your transactions in a PDF file. It's the world's most generic output, but also the world's most common output. Luckily, we won't do that in this class. And then the controller, which is the user interface, listens to the user in order to request data or state in the GUI and notify the model or view accordingly. So this is a generic organization of your software, right? It makes it logical, or makes it easy to follow the organization. It also helps separate the different subsystems from one another. So if you imagine the controller, if you're able to abstract the controller out away from the view and the model, you can swap one controller implementation for another. And in the coursework, you're given the controller implementation. Does anybody know what the controller implementation is in the coursework? You'd have to be really awake to answer that question. Anyone know what the controller implementation in the coursework that you're given is? Anybody want some sugar? It is Java Swing. You're given an application in Java Swing. Anybody know what you have to replace it with? Java Effects. Did you say that? Yes. So that's the controller. If you do really good software design, then swapping these things is easy. In practice, it's usually not easy because the design is usually not good. But in theory, if you've done your design very carefully, then swapping these is not difficult. Okay, and flexibility. We can swap things, components and upgrade components without breaking the other subsystems. Right? We could theoretically swap our data access, one database for another, or we could put our database on a network and not break the other components. And somebody was having a discussion about this. In a lot of applications, there's overlap between the controller and the view. So, for example, in the visual paradigm application, there is quite a lot of overlap because you're drawing right on the canvas. And so the area of input and the area of output overlap. So there's some strong coupling there, and that happens a lot, right? So that's a visual representation of that kind of thing where they're very, very closely associated with each other, and they may not be so easy to separate. In this example, there's a two-way communication between the model and controller, but a one-way communication between the model and the view, and a two-way communication between the the view and the controller. So in the push architecture, that's represented by the directed arrow, the one-way directed arrow. In the pull architecture, that's when the arrow is facing us, right? And it's up to you how you want to implement that, whether or not you want to support both directions of communication. Here's another example, right? Here's the controller subsystem, which is the GUI. This is the view subsystem, which is the output. But if the user can make modifications directly onto the canvas, which they can, then there's going to be overlap between the view and the controller in the implementation. Can anybody think of a way to handle that? Is there a way to do any kind of separation there, even when there's overlap like that? Name? Did you raise your hand? No?
Try answering anyway. I don't know, I use a bridge, I guess?
That could be a possibility, use a bridge. Imagine a Venn diagram. And you have one ellipse that represents all the classic GUI operations, like right here. And then imagine another ellipse that represents only the canvas, the output. And then you overlap the two ellipses, and that they have an area of overlap, the responsibilities that overlap. You could organize your code that way, right? So there's going to be some responsibilities that are purely GUI oriented or purely controller. Then there are going to be some responsibilities like rendering that are purely view responsibilities, and then there's going to be some part that's overlapping. So that's one way. So the idea would be to identify the overlapping components and put them in their own class. That's the idea. Okay, so there are lots of resources and documentation and tutorials on design patterns. Here's one of them. Oh, this one's little reference cards. So if you need like a little summary on a tiny little reference card, that's very handy. Here's another one. Someone is asking about what Java support there is. Here's a resource for design patterns in Java. Good thing to have a look at. Here's another resource on design patterns in Java. Oh, so wait, this might not be for Java actually, but it's another, you can see there's quite a lot of documentation here. Okay, any questions about design patterns? No? Anybody want a piece of Halloween candy? There are 3 pieces left. This one's really bad, by the way. This one. Anybody like sugar? Okay, who does anybody mind if we end early? Are there any objections? We'll have some time for questions. Who wants Halloween candy? What's the question? Can I throw that far is the question.
So go back.
Back, okay. Going back. This one? Singletons.
Yeah, the code example.
Yes, has a mistake. Did anybody, so somebody noticed there's an error. I have to admit there's an error in there. Ouch.
No, I had a question about the code though. What's the difference between having a private and public constructor? I know the difference between public and private, but why constructor?
So a private constructor is going to be necessary for the Singleton design pattern. You don't want anybody to be able to call the constructor at any time.
But I thought only the object could call it when it's first initiated.
Only, like in this version, it's only instantiated in this method called getInstance. So there's no explicit constructor that's like generically available outside to the outside world. The constructor is private, and this is like a key characteristic of the Singleton. It's saying there's only one class that's allowed to instantiate the Singleton, or that object which is a Singleton. So it's like having tight control over that instantiation, that one line. This is like saying, look, I'm putting it in this one line, and only one object has access to this, and therefore we can make sure it's a single instance. Does that make any sense?
Yeah, thank you.
I don't know if this is gonna reach up there, it's too light. Any other questions? I know that some of you have questions, but since we're ending early, you'll have plenty of time to ask them in the next 20 minutes or so. Okay, thanks everybody. We'll stop. If nobody minds, if anybody wants to object, let me know.